Kentic is cloud observability for network nerds, unifying hybrid and multi-cloud network telemetry so you can optimize cost and security at scale.
Not to mention, Kentic AI is available for you to easily access all that data without even needing to learn KQL or spin up your Elk stack.
Find out more at the break.
Packet pushers.
Welcome to Day 2 DevOps, where the DevOps is in the details. I'm Ned Bellavance, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on day one and beyond. With me on this journey of learning and doing is my co-host, Kyler Middleton.
Hey, Ned. Today, we talked to Adam Jacob of System Initiative, one of the previous authors of Chef, about a new paradigm for how to build and manage infrastructure. We talked about how the current generation of infrastructure as code tools are amazing, but limited in how they are linked to Git and how they're a static snapshot of your infrastructure rather than a living, breathing diagram that refreshes automatically. And how if you create a digital twin of your application and infrastructure, you can have a more comprehensive understanding and a safer, change methodology when you're making changes to these big complex systems. We used some incredible metaphor like your infrastructure and applications are a multiplayer game. We're all playing together. And how AI is technology and not magic, and you can invite it to be a player in this multiplayer game of your infrastructure architecture. So, guiding us through all of this today is Adam Jacob of System Initiative.
Well, Adam Jacob, welcome to Day 2 DevOps. We're super pumped to have you here. And before we get into the topic proper, I want to start with an easy question, something simple.
Hit me.
Who is the absolute best death metal band of the 90s, and why is it Gorguts?
This is an excellent question. Gorguts is a fine choice. However, Death, the band Death, was still happening through the 90s.
That's true.
And I'm just going to always give it up to Death. That's my band. That's my jam. And perhaps controversially, I liked later stage Death more than I liked early stage Death. So I like it even more in the 90s, which, like if I was, hardcore enough, then I would be saying that they peaked in 85 or whatever, but no.
Well, I feel like we're going to get some feedback just around that.
Yeah, Gorguts is a great band. I love Gorguts, but I would take Death. When was Left Hand Path? Was that also in the 90s?
That might have been late 90s.
Yeah, right? Because also incredible record. So anyway, there's choices.
Important stuff. All right,
Yeah.
So we're going to scrap the rest of the episode. And for the next 45 minutes,
We're just going to talk about metal.
Kyler, I'm so sorry.
Ned was trying to get me to listen to some of these bands, and I was just nodding as fervently as I could with no knowledge of what y'all are talking about at all.
This is the reality. That's the podcast I want to be on. So no one's inviting me to be on that podcast, but if they did, I would be a killer guest.
Well, that just means you have to start one because
Yeah.
I'm sure that you have time to do that.
Yeah, right.
Ned will be guest number one.
Amazing.
Well, now that we've established the new direction of the podcast, I suppose we should actually talk about the real thing, which is you and System Initiative. So let's start with you. How did you get into the world of technology and end up writing this thing?
Long story short, I'm a systems administrator. People remember systems administrators. And, I got my start building ISPs in the 90s. And then I worked for a series of companies. What happened to ISPs in the 90s was consolidation. So they got tiny ISPs that were in the back of dentist's office, got consolidated into big ones.
Mm-hmm.
And so I started building the automation that would help consolidate ISPs, right? So it would help, you would acquire one and then you'd have to take all their customers and get them onto shared infrastructure. And then I went to work for a long string of companies who basically had that as their business model, only for other verticals, targeted ads or domain squatting or whatever. And our job was to basically build the shared infrastructure so that we would buy a plateaued company. I wasn't buying it. I was the systems administrator.
Right.
We would build this platform of automation that would make it really easy to then onboard technology we'd never seen. And so I just got really good at understanding people's application architectures and designs and then porting them and designing some kind of general automation framework to adopt those things. And then I became a consultant and we did that for startups. And then that turned into writing Chef, which then turned into a decade plus of my life helping do configuration management and DevOps and all of those things at scale and all the biggest enterprises in the world. And then that led to System Initiative. That's the TLDR.
So as someone who used Chef, thank you.
Mm-hmm.
And how dare you?
One of the things that is fantastic about having some like modicum of success. Like it's amazing that there's people whose lives were really changed by Chef, and it's always amazing to hear that. There's also people who like really didn't like Chef, and like those people show up too, you know? You kind of have to take it all. The good comes with the bad, you know? Like over time I've learned to relate to all of that stuff more like art, you know? Like Chef was great art. And whether or not it was the art you like, you know, we were talking about Gorguts earlier, and I think Kyler was like, I don't want to listen to Gorguts. But like, that doesn't mean Gorguts isn't great. It just means maybe it's not her jam, you know?
Yeah, absolutely. And I got exposed to Chef and Puppet right around the same time, and Chef was definitely more my style. I know, Kyler, were you more into the world of Puppet, or did you avoid that entire mess entirely?
I avoided it entirely with mostly network engineering at smaller scale, but I do love the metaphors with the knife and the chef and the like
Recipes and stuff.
recipes. Absolutely.
Yeah. We threw great conferences. I mean, the Chef's still around. We're talking about it in past tense because I'm no
Yeah.
longer there. But the product is like fantastic. It's doing well. Like,
Yeah, it pops up in random places. I was trying out the various test suites for Terraform a while back, and one of them leveraged InSpec as the engine for doing the acceptance test. And I was like, oh, it's back.
InSpec's an incredible product. We acquired the company who built InSpec initially. But yeah, Dom and Christoph have another startup that they're doing now. InSpec was great technology.
All right, so Chef, that's old news.
Sure.
But now you started a new thing called System Initiative.
Mm.
What's the big problem that you're trying to solve with this new thing?
Yeah. So, you know, when you think about DevOps, we just had like the 15th anniversary of the first DevOps days in Belgium, right? So let's call it a little more than 15 years, right? So whatever, 18 if we're Patrick Dubois and John Allspaw. And over that time, we've had like a ton of different technology come and go in the stack, right? Like you can sort of tick off the number of changes, right? I think Git happened in that era. Cloud computing happened in that era. Kubernetes happened, Chef and Puppet happened, Ansible happened, Docker happened. Like we can keep going. CI/CD blew up. We all stopped using just Hudson, and then we were using Jenkins. Now we're using GitHub Actions. Like all of these technologies have come and refined what was the same essential shape of automation that we were doing almost 20 years ago now. And the shape hasn't really changed. And what's interesting is if you look, my experience helping do this in the large enterprise for sure showed me this, that it's quite hard to actually put all this technology together in a way that leads to good outcomes all the time. And you tend to see this in the big enterprises where all the best of intentions, all the right tooling, but if you get it a little bit wrong, if you design how they all interact together just a little bit off, then suddenly the outcomes crater, right? And it goes from fantastic to like kind of mediocre. And you can see it in like the Door report where like you can be a high performer in DevOps now if you can deploy once a week with a 50% failure rate, which if you think about what we wanted, that's not what we said we wanted, you know? Like that's not where we believed we were going, but it is where we've landed. And it seems to be landing that way kind of in a way that is resilient to technology changes. Like we put Kubernetes in, did we get better? Not really, you know, like it might be better in terms of like the way it feels for an engineer, those sorts of things. But like, is it better? The outcomes aren't better. And so for me, you know, I spent a lot of time helping people understand that. And I just got to a place where as I was leaving Chef, I kind of realized that the problem was the system itself, like the shape of how the system works and the primitives that we built it on top of were insufficient to the task in now. And, you know, that actually starts with some really deep held assumptions about how these things should be constructed, like that we should be writing source code first, and then we should be treating our infrastructure code the way that we treat applications. And we should be putting them into pipelines, and we should be like running them like artifacts, and we should be synchronizing their state, and it should be declarative. And like all these things that I had spent my whole career building on and believing, I kind of came to the conclusion that we had sort of reached our logical end, that angle of research and that entire direction had basically peaked. And it wasn't going to get better. We could move the edges. We could make marginal improvements on individual pieces. But if we wanted an order of magnitude better experience, if we wanted it to actually be better, we were going to have to find some new primitives that allowed us to actually build systems that would work in a different way. Because the problem was how we were asking each other to work, not that the technology that we were using to do it was wrong. And that's why we started System Initiative.
Ned and I are both thinking, like, I can see Ned and my gears like both going. I want to dig into what are the assumptions that we have that are wrong? Is that jumping the shark ahead of the narrative here?
No, I don't think so. I mean, it sounds like a conversation to me. Look, I think there's a bunch, right? The first thing begins with the idea that infrastructure is the same as an application. So, like,
Mm.
when you think about the tools that we use, like when you write software and then you think about how you're going to package up, test, distribute, and deploy that software, there's a lot of commonalities across software, across stacks, right? Where like essentially we kind of know what the shape is and it kind of holds pretty firm across a huge number of different kinds of software applications. Infrastructure, though, it's not the same. We need it in order for the applications to run, but it tends to exist somewhere physically. Software doesn't. It tends to take longer to change. Software doesn't. It tends to allow you to change in multiple ways without anyone noticing. Software never does that. When's the last time your software wrote itself at random? But like, your infrastructure can catch fire. It can like burn down and then it's not there anymore, no matter what the software says. That doesn't happen to software. Like there's a million different pieces of that property that are different. And yet, our best sort of bet for how to manage it at scale was, well, let's write software that reflects what we want to see in the world and then sort of run that software and hope that it can reconcile with the world. It works, which is amazing. Like I've helped build some really large infrastructure and, Chef was used to power Facebook and it was used to power global banks. And like the techniques we used to do that, I'm so proud of them and they really worked. And when you really think about it, there's a weird mismatch between the actual domain, the thing we're trying to automate, the thing we're trying to build, and the primitive we're using. And then once you kind of come to that conclusion, all the other choices we make also feel weird. Why would GitHub pull requests be the preferred way of working, where the outcome is physical infrastructure over a long period of time that changes all the time? It's like a very awkward fit, right? It makes sense because you have hammers and nails, but like, is it good? I mean, it works, which is amazing. But like, is it right? Like it isn't, right? And you can kind of feel that it's not. So the question was, what could be better? And for us, where we came to, and it's taken years of R&D. This wasn't a fast thing. It's not like we started System Initiative last year and we're like, baha, like it's been 5 years of real hard research to figure it out. First, you have to think differently about how the stack is constructed. So when you look at other industries, one way that people deal with this is they think about the data differently. So this idea of a digital twin, where you basically take, think about manufacturing is a good place to do this. We don't send people down into deep mines anymore. We send robots. And the robots have a digital twin up top on the surface where somebody is like using a machine that is like a mimic of the robot and telling the robot what to do. Or, we build digital twins of physical spaces. So like we build big 3D models of buildings before they actually happen. Or we actually map physical spaces and then build 3D models that you can then traverse or experience in different ways. So what we started to do was build digital twins of digital things. So instead of thinking about it as an abstraction, we were like, well, what if we just tracked the data in as like high a resolution as possible? So, you have this piece of infrastructure that you want to use. Let's model that in as much detail as we can. And then once we have that information, now the question is, how can I simulate it? Because one thing people do with digital twins, like think about Formula One cars. Formula One race cars, they only have a very limited testing window. So what they do is they build really elaborate simulators, very elaborate digital twins of the race car so that they can tweak setups and constantly try things virtually without actually doing it. And so that's similar to the problem we have in infrastructure. It takes a long time to build infrastructure. It takes a long time to get it set up. It takes a long time to know if it's going to work or not. So if we have these high fidelity models, then we could start to build simulators that give us feedback in real time that say, oh, this won't work at all. Like just like if you took a race car and you pulled the rear wing off of it, it would fly off the racetrack and you'd be like, don't pull the wing off. Like we can do the same thing in infrastructure, right?
Right.
Then you have to figure out how to make it powerful again. So great, I can construct these models. Now, how do I make it so I can construct them in a way that's as effective and efficient as it was to write them to do declarative infrastructure code? And our answer there was to flip it over so that those models get constructed as a series of tiny reactive functions. So basically, think about all of those models as each property of every single thing is the result of a function that's reactive to its inputs. So you say, I want to set the name of a Docker image. What you're doing in that moment is calling a function whose input is the name you want and its output is the string, right? Just an identity function. But then later on, maybe I want to reuse the port number that's exposed in that Docker image as the input to my load balancer's pool, so that it knows what port number to access when we're load balancing stuff. And that can just be a relationship, right? That's expressed as functions, where if the Docker image's port number changes, recalculate the pool entry for the load balancer, right? And so now you can program not only a single model, but the interrelationships between them. And then now the new challenge is, how do I put those relationships into this model? Because if it's just programming functions, it becomes a little hard to reason about it. Like you can't see it and it gets very weird and like difficult to think through. And so we put this multiplayer user interface on top of all of that, where you basically work with a living architecture diagram where each component is this high fidelity model and you can set its properties, and you can also draw lines that express the edges between those things, which are actually inputs to functions.
I'm going to pause you for a second because I had a little epiphany when you were talking about all these relationships and these different entities and the way that they're interacting with each other.
Yeah.
And you know what I thought of?
Tell me.
Access, Microsoft Access.
Yeah.
That's what I thought of, because that's how you built stuff in Access. You would
Yeah.
like drag these tables and then you would create relationships all visually between the tables, and you could define functions for that relationship.
Yes.
And that's kind of what you're describing. It's a database of sorts.
Yes.
With these relationships.
Yes.
With a visual component.
Yes.
It's Microsoft Access for infrastructure.
Yes. Or if you get even older and more accurate, it's Smalltalk for infrastructure.
Talk. God, I haven't heard that term in forever.
In many ways, it has more in common with like what Alan Kay was doing in the early 80s than it does with like infrastructure as code. It's like a completely new branch of philosophy. But if you think about modeling use cases, it can really open your mind. Like think about application deployment. If what you're doing is not expressing it as a pipeline, but as a series of reactive functions that transform a graph, like it becomes much more straightforward to model. You're like, okay, well, what do I have? Well, I have an application. It has properties like a version number, has environments it's going to go to. It has relationships to the infrastructure that run that application. And then we describe what we want it to do, the activities we want to take as a transformation of the information. And we can do that in the simulator. So we can do that first hypothetically and be like, okay, you want to deploy the app. Great. What are all the changes that would happen to this infrastructure when the application deploys? And we can show that to you and you could see if you like it and if it makes sense. And then when you apply it to the real world, it tracks your intent and knows, hey, in order to do this, I'm going to have to change the infrastructure in the following way. And what pops out the other side is your application deployment. And like, it's so much more straightforward in many ways than the way we do it now, right? Or think about, finance or security, right? Like you should just write a security policy that's reactive to its inputs. I want to make sure that every Docker image in my entire enterprise only comes from the vetted, trusted registry that does supply chain security. That's like a 15-line function in System Initiative, right? You would just attach it to all Docker images everywhere. And then if anybody tried to use one that didn't use the right registry, it would turn red. And it would be like, nope. And then it could tell you why, right? And if you think about trying to build that kind of policy in the structures we have today, it would take forever. It'd be such a pain, right? That's why we built it.
And I'm trying to understand that, but I'm using the frame of the tools that I'm used to, these declarative like Kubernetes and Terraform. And of course, yeah, that would make no sense at all. And I have worked with teams that sort of marry application and infrastructure deployments together as we promote through. And it means that if you have like a critical infrastructure change to make, well, like, oh, it'll be to prod in 6 weeks, because that's how long it takes for this code to get promoted and smoke tested and blah, blah, blah. And so being able to virtualize and build this like digital twin, I love that analogy, by the way, because that really helped me, of your infrastructure and applications together and be able to see the impact of changes on both of those layers. That sounds really powerful.
In real time, by the way, like you're using Notion or Google Docs, not like a pull request. Like you come together literally in the interface at the same time and do it together.
This is such a change from the way that we approach infrastructure as code today.
It's bonkers.
It's wildly different. And I've always felt that infrastructure as code was a bit of a kludge because, like you and Kyler also, we all came up as sysadmins and engineers. So we came from the infrastructure side.
Yeah.
And when I learned how infrastructure as code was structured and how it was leveraging these software development principles, some of them fit okay, but some of them really, really didn't.
Some of them are brutal.
Especially when we got into testing and trying to apply testing frameworks like
Yeah.
unit tests and acceptance tests. And I'm like, none of that makes sense, but I'm going to hammer that square peg into the round hole as hard as I can.
Yeah. Because I do want the faster feedback loop,
Right.
right? Like it is expensive to see failure at runtime, right? Like, when you're building Terraform or Pulumi code, like it understands the syntax of Terraform and the syntax of Pulumi, and it can understand like this is a well-formed string, like this is a cider block, but it doesn't know what it means, right? It doesn't know what the relationships are. It can't tell you if it was good or bad. So like a lot of the time, how many times have you run a Terraform plan and had it say everything was cool?
Mhm.
And then you go to apply and it's like, not cool. And the answer is a lot.
Right.
And the bigger that repository gets, the longer it takes to learn what's happening. And the analogy to me is sort of like, it feels a lot like you're piloting a submarine, and like you can only just like talk to people over radios. Like every step in the process is a separate submarine. And I'm like in my little submarine area and I can't talk to anyone else. And I'm in my little hermetically sealed cave and I'm like, deploy application, And then somebody else far away is like, oh, check, application deployed, like then an hour later you learn that everyone's dead and you have no idea why. It's an interesting balance to walk because I'm not saying that the technology is bad. It's not bad. It's manifestly good. Like what we have done with it over the last 15 or 20 years compared to where we started, insane, right? I'm so proud of the progress we've made. I'm proud of my own role in using those techniques to move it forward. And also having the privilege to step back and enough expertise and people around me to start to find a different path. It's become really clear to me that like there are absolutely more viable paths and that we need to explore them because like the shape of how we can interact and how we can program the systems and how expressive they can be is wildly better. Like we can do wildly better than we do now.
Kyler, can you create a line chart for me of the top talkers on our Azure resources over the last week?
Well, I could. Just give me maybe 2 weeks to learn Splunk, KQL, graphic design. I'll have something to give you maybe next month. Or, well, we could ask Kentix AI and have results in just a few seconds.
Really? What else does Kentic do?
You know how cloud networking feels like this huge black box sometimes? Like, what are these network egress fees? Is this huge traffic spike impacting page load times? Is this security policy blocking the right traffic?
Yeah, and not to mention, how do I show this dev team that they need to build caches locally to cut down our cloud bill?
Exactly. Kentic is cloud observability for network nerds. It puts all of that mysterious cloud networking data into context, and it has this super fast engine for analyzing and visualizing it.
So you're saying it gives you not just the ability to see the data, but also to understand the data.
You got it exactly. And our listeners can too at kentic.com. Oh, and here's that chart you asked for. Turns out the top talker was you, Ned.
I like that the metaphors that you've been drawing on are from manufacturing and actual infrastructure, not IT infrastructure, but true infrastructure, whether it's buildings or cars or something else, because that does seem the more natural analog than trying to attach it to software.
Totally. One of the earliest experiments for System Initiative came from looking at when you manufacture like an airplane, how do you know how many bolts you need?
Well, don't ask Boeing, but yeah.
But it's an interesting question,
Yeah.
right? Like, obviously they know because just-in-time manufacturing tells you that they won't hold stock. They're not going to have like a giant barrel of bolts just like at random. They know precisely how many bolts are required to build an airplane. How do they know? How's that any different than saying, well, I want to design some infrastructure. How many servers do I need? How many whatevers do I need? And so that's how we got to these high fidelity models. We started out thinking of it more like people, I think now are thinking about AI, where it was like, how could I express as little about what I know about infrastructure as possible, but get a working outcome? And those prototypes worked, which was kind of amazing, but they were really frustrating to use. You always knew what you wanted in the end. And so you were like playing golf with the system to be like, how many hints do I have to give you to get the exact thing I knew I wanted from the jump? And it wasn't better to use.
Right.
But yeah, the other analogy that's not just manufacturing that we were really inspired by was like people who build giant video games. If you think about the complexity of, the Elder Scrolls or the complexity of Grand Theft Auto or of World of Warcraft, how do you have a team of people who are working cross-disciplinary, right? You've got artists, you've got 3D renderers, you've got programmers, you've got quest writing. There's all these tasks people are doing. They're all collaborating on this incredibly complicated thing that has to all come together at the same time. Same with like movies. When you're doing special effects in movies, huge number of disciplines have to all collaborate together on the same essential artifact. And they do not collaborate the way we do. Like if you look at every other industry, this is not how they work, right? And so, yeah, we drew inspiration from all of those things to sort of get here.
I'm so curious what your vision of collaboration looks like with system initiative or something similar. So, take a typical platform and application team that you might have in an organization today and the way that they collaborate and interact. How would that same grouping work to get an application deployed on infrastructure using this new process?
Yeah. So I have to draw some distinctions between like today and in the grand scope of the universe.
Sure.
So like today we're quite focused on the infrastructure layer. And so we have teams that are working right now actually to help build some of the higher level semantics that make some of what I'm about to talk about possible. So here that there's like where the product is right now, and then there's where it's going to be in the not so distant future. And I'm a little talking futures. But the way that this will work is if you think about the fundamental primitive, which is, okay, I can build you a model of anything you want. You can build those models inside System Initiative. They're just basically TypeScript functions that define the model. So you define this model and you define its behavior by writing functions. And so what we would do is think about the different semantics that people want to operate on the model in. So if I'm an infrastructure person and I'm responsible for the infrastructure, I'm thinking about things like servers and databases and clusters and Kubernetes and all those details. If I'm an application developer, I'm thinking about things like application deployment. I'm thinking about starting and stopping the application. I'm thinking about moving its trace level and log level up and down. There's all kinds of stuff I might want to do. So those things will get encoded into a model of the application as a high-level construct. And it'll have relationships to the things that it cares about in the infrastructure. And then each of those different roles might have completely different user interfaces, right? In the same way that like programming, writing an editor is a thing you do in Unity. But if you're working on a scene, right, they don't make you write the scene as code.
Right.
You like use a scene editor and you like move the things around to get it done. So there'll be an interface for infrastructure people. There's probably an interface for application people that like uses those higher level models, but is attached to the same underlying data, but is specific to the job to be done. But they relate because they're all coming together in the same data model. And they're all updating constantly in real time. So the whole thing's multiplayer. All that data is changing. As it changes, you're seeing it happen across these different interfaces. All they are is different semantics to the same underlying information, which is what the hell's happening in my infrastructure, in my applications, in these different spaces. Another example would be like finance and cost control. So you want to have cost analysis that tells you like, hey, I want to make this infrastructure change. How much would it cost? So that's easy to imagine how you'd model in System Initiative, right? It's just a function that calculates the cost of whatever you're doing and then takes the output of that, stores it somewhere, and then you build an interface that, tallies it up and shows you what it is. But you probably wouldn't want to send a finance person into the same living architecture diagram that we're showing infrastructure people today because they would be like,
Right. It's different views into the same model, but that view is customized based off of the job that is behind it.
Yeah. Just like you would do in CAD or in manufacturing or in Unity, right? We all have different roles to play. Same video game, same scene of the movie, but we're operating at different layers of that information. We play different roles.
I love the term multiplayer. I'm going to use that all the time now. So my job is multiplayer with all the other players in the room trying to build and trying to keep my product up.
It's so much more fun to do multiplayer, by the way. One of the greatest moments in System Initiative's life was we used System Initiative to run System Initiative. And like watching our team build the production infrastructure in System Initiative in real time by just logging into the workspace and joining the change set. And there's like 4 or 5 different people and they're working on different sections. And like you can watch the architecture sort of pop into life. It was moving. Because I remembered what it felt like to do that sitting next to my best friend, like building ISPs and how much I loved that, how much fun we had. And I didn't know I missed it, Like I'd been such a part of building all the tools that brought us to like, okay, I write code alone. I put it into code review. Somebody else reviews it alone. And then we talk about how we're collaborating, but we're not. right? We're actually just like, and then I wait for you to wake up because we're a distributed team. And so 12 hours later, you finally get around to looking at my code. And like, ugh, I didn't know how much I missed just like having friends who like worked directly on the problem with me in real time. I don't know. I loved it. Is that weird to say?
No.
No. Other infrastructure as code tools like Terraform, OpenTofu, you're representing your infrastructure in code, and that's committed to a repository, which kind of
Yeah.
locks it in place, which sounds like something that we don't want to do here with System Initiative. So
Yeah.
how do you propose changes?
Yeah.
Are you writing change sets that are applied like a batch?
Yeah, that's such a good question. And yes, that's what you're doing. The hard part there is that instead you can't bake it in. You know, like you don't commit your database to Git, right?
Right.
It wouldn't make sense, right? And it would be infuriating if you did, right? And so, and in the same way, you don't like commit System Initiative to Git because it doesn't make sense. So what we had to do was basically when we built this reactive graph, we actually call it a hypergraph of functions, which if you're a big graph nerd, you're going to be really annoyed that I use the word hypergraph because a hypergraph is a graph where an edge can have multiple nodes at either side. That's not what this means, but I didn't know that until I'd already stolen the word and it kind of stuck. So sorry, graph people. But anyway, we have this hypergraph of functions. And what we mean by that is that when you create a change set, what you're really doing is building a completely separate instance of reality. So it goes from like, there's the real data that's happening and it's tracking all the real information in the real world. There's all these components that are the hypothetical ones. You create a change set. Now you have your own completely isolated view of the world. And that's what you're manipulating in the simulation is this isolated instance of the same data. Think of it just multidimensionally, right? Instead of a flat graph, it's a cube of graphs. And then what happens is as you do this work, we're calculating the delta, the transformation between what you say in your simulation and the representative of the graph, we call it head, because it seemed like a good word to steal from source control that's tracking the world. And then when you go to apply it, instead of tracking the declarative intent, so like, you know, when you're using like Terraform or Pulumi or Kubernetes, what you're recording is declarative intent in the source code. So you're saying, I changed the declaration. Then the system's job is to figure out the transformation. One of the things that was most surprising was that once you could visualize the information in this granular way, you didn't need to do that anymore. Instead, it was actually easier to record the transition. So you can say things like, in this change, what I want to do is, like in Terraform, if you changed a tag on an EC2 instance, it's going to destroy the instance and boot a new one, which is insane, right? Like there's a perfectly good API to update the tags, but you don't call it because that's not the model. And so in System Initiative, that would be trivial. You would like change the tag, and then there's an action called update tags, and you would be like update tags. And then you would see in the change set that what it's going to do when you apply it is update the tags, right? And it makes sense and it's a lot easier to reason about, especially when it breaks, because you can see the relationships between those actions that you want to take. So we're recording not the declarative intent, but the imperative flow of the actions you would take. So if you did want to like destroy an instance and then create a new one, you can totally do that. You would cut and paste the instance, right? You'd like literally copy it and make a new one, tweak it, delete the old one, and it would record your intent, which is I want to create one and then delete another one. And then when you apply it, it knows what to do. I was stunned by this truth because I had spent my whole life being like, obviously the system must be declarative, but like it turns out it's not better. It's worse if you have this other primitive. If you don't, declarative all day. But like if you do, it turns out it's better. And then one last thing about change sets. So we declare all this intent, you remember all this stuff. The other cool thing it lets you do is transform them in real time according to how things change in head. So let's say the three of us are all working separately. Kyler applies hers first. My open change set and Ned's open change set both get the changes that you make streamed into our change sets in real time. So you never have to be like, oh, my branch is out of date. Or, right? So if Ned was working somewhere and was like, I expect this infrastructure to exist, and then Kyler deletes it, it's going to disappear from Ned's branch because it's gone in the real world. And Ned's going to be like, Kyler, why? You know? But what he won't do is get to keep working for another couple hours, blissfully unaware
Right.
that the universe has actually been altered underneath him. So you can think of it as like both this multidimensional thing that's very cool. It also is basically like an auto rebasing branch where reality is always keeping you up to date.
That might actually answer one of the questions I had, which is how do you deal with change that happens outside of system initiative? Because sometimes humans go in and tweak things in the AWS console or the Azure portal. Sometimes something just happens on the platform provider and they change something. How does the model get updated to reflect that?
So we track both sides, and they're both true in their own context, right? So there's what you say you wanted. That's what we call the component. And then there's the resource, the actual thing in the world. And so that resource can update on its own, and we can refresh it and be like, well, tell me what the real state is. Right now, we're actually experimenting with the fact we used to do that automatically on an interval. So we would just refresh it all the time. Interestingly enough, like it very rarely changes. And so we've actually made it so that now the refresh is kind of manual. And it seems to not be a problem, which I'm just waiting for it to be a problem again. Like it feels instinctively to me, like as a product person, they should refresh automatically. But when I turn it off, no one seems to care. That's an interesting smell. But anyway, like I don't know what that says about the state of the universe, but we could turn it back on so it was automatic. But either way, those two things are different. And because what you can do is build different kinds of visualization, right? Now that drift detection is no longer a question of how do I reconcile? Like right now, what you would say is only use Terraform because otherwise it'll drift and I'll undo your changes bad. And I think what you want to live in is a world where it's like, if it's an emergency or you just knew what to do, just do it, however it happens. And then what you want to see is a record in System Initiative of the fact that that thing changed. And then you can look at it visually and be like, well, do I like the change? And I went into the console, change these properties. Like, if I like that, then I should just make the component reflect your changes. And now we're good. Because again, it's no longer about a declarative loop where you're like, oh, your declaration was wrong. And I don't know how to transform the code because you factored it weirdly or I didn't understand it. And so I can't keep them in sync because it's all just a data model and it's all one-to-one. It's as high fidelity as we can make it. It's really just a question of like, well, did you like it? Because if you do, just update the component and now that's the way. But it's not going to like automatically change how the infrastructure works. So System Initiative is never going to come in and be like, oh, I better revert that because it doesn't make sense to revert it because that's not what infrastructure does, really. Like it's usually there because it's doing something useful. So like if it changed, sometimes it's wrong and you can fix it and that's fine. You can detect it and just make the change, bring it back. I didn't mean to delete it, But most of the time it's not. Most of the time it's actually people doing the right thing the wrong way.
Okay. So another big thing about infrastructure as code is the idea of reusability of code.
Yeah.
So writing modules or recipes or whatever terminology you want to use. How do I encode those kind of patterns or reusable components in System Initiative?
Yeah, so this is the thing that we're working on right now, but it's essentially this idea of like a management function that sits on a component. So think about these components as universal. They can exist at different shapes and sizes. But one of the things you want to be able to do is transform and manage other things. So when we use like a Terraform module, in a way, what you're getting is a template, right? That says, I feed in some attributes and then it pops out some infrastructure. So a management function can do the same. It knows how to manage different things of different schemas. And you can write these functions and what they return are things like, hey, create me the following set of models with the following sets of properties informed by whatever I wanted to inform them by, and then like position them however you want to in this diagram. Right. And then so you would have like an asset that's like an AWS standard 6 subnet VPC, right? Where 3 public, 3 private with a route table and a network gateway. And you could just basically build that thing and it would have a couple properties like how many subnets do you want? What's the root CIDR block? And it could have a qualification on it that like does the CIDR block math and says, hey, I know you said you wanted 6 subnets, but the initial CIDR block you gave me wasn't big enough to support 6, can't split it 6 ways. So that's an error before you start. And then when you're ready, you then would run an action, a function on that component that would say, create me the infrastructure or like show me the infrastructure. And then it'll have a little ghost and you'll drop it on the diagram and it will expand to show you all the stuff that it would do, right? And then it has a little edge back to the manager. And then you could use that to write other functions that transform it day 2. So the other thing that's good about that modular approach is that often what happens when you go too far down the modular road is that you have all these tiny exceptions. And so either the thing that you modularized grows to be a full mirror of the complexity of the thing it abstracts. I call this the 200% problem. We saw this in Chef where we were like, let's just put every attribute of every possible thing in a single module and like solve Apache 2 forever. And we thought that would be better. And it wasn't better, it was worse because it meant you still had to know everything about Apache 2 to use it. And you had to know everything about how Chef worked in order to understand how we translated Apache 2. It was infuriating. And so toward the later stages, we wound up having smaller modules that did less, but were easier to comprehend for individual people. And so what's cool about the system initiative approach to this is that like those models you can then tweak by hand. So like, if you use that management node once to do something, you could then be like, oh yeah, but I want the route table to be different. So you could just make it different instead of like trying to change the abstraction of the root level module to pierce the veil or whatever, because you don't want to, right? And then you contribute that back all inside system initiative. So when you're programming this thing, you're doing it inside the application, and there's a little button that says contribute. And when you hit it, it's like, are you sure you want to contribute it? And here's what the license would be. And you hit a button, and then we vet it and put it back into the product.
Interesting.
Cool.
I feel like I need about 3 or 4 more hours to fully grasp it, but we're
Correct.
coming up on time.
Look, this is a common problem because I'm also like a little pent up. Like I've been like doing all this R&D for 5 years, and now the machine fully works. And so I'm like, oh, I'm like vibrating to tell everybody how the whole, like all these, and you told me earlier, like go deep. And so I'm like, oh yes.
And we did. Yeah.
And we did. And now you have regrets, and that's on me.
First of all, 0 regrets. I agree with Kyler. We could stay on for another 2 hours, and I have so many more questions.
I'm good if you are.
I think our audience would be very sad if we kept. Well, actually, I don't know.
I don't know.
It's hard to say.
My kids would be very sad because they're expecting me to appear in about 10 minutes.
That's a good reason.
Yeah.
Our capstone question on almost all of our interviews this whole year is, where is AI tied into this product, if at all? Is AI a component of building these digital twins?
Oh, for sure. So I think the first thing you have to do is, just as generic advice, is you have to approach AI as technology and not as magic.
Mm-hmm.
So if you look at what the technology is and what it can do, it is very cool technology that can do a bunch of interesting stuff. I think one of the things that's holding us back is that the way that we've thought about building our operational systems is just text. It is just code. There is no model. And so kind of the best you can do in infrastructure is be like, I got better at generating Terraform, or I got better at generating Pulumi code. And then you're like, well, but that's complicated because my repo is complicated. And so then I need it to like understand more context and do all this stuff. So I think when we think about AI, we think about it primarily as another player in the game. So because everything is multiplayer and all these models are reactive, what should be happening is you should be able to ask the AI to do things for you and then see immediately what the results of that are, as if a human being did it. So, and a good example, the first place we'll probably see this is in authoring new assets, where like AWS launches an API that we don't cover. And I think the feature will be that you'll be able to go into System Initiative and be like, oh, hey, AWS launched this new service. Here's the documentation. Build me the assets for it. And then in a change set, it will just go do that for you, because it can be really effective at writing all that code and translating between their very good documentation and our modeling language. And then you can just inspect that in a change set and try it out. You can be like, great, here's the components and here's the connections it drew for me, and it did a good job or a bad job, because you'll be able to just interact with it right away. I think another way that we're going to incorporate it is, it just makes sense that you would be able to ask it to analyze what you see and like propose changes, or even sort of create net new infrastructure from scratch, because there's no reason it couldn't just be like, well, yeah, if what you want, if you said to it, like, give me a 3-tiered application architecture using the following AWS services, then what would happen is we could take it and just have it act as an agent that looks like another player in this multiplayer workspace. And what you would see is those things popping into the architecture diagram and the AI connecting them. And then you would see it qualify like a human had written it. It'd be like, it would be 90% correct, but these, a couple of properties are wrong, and they would turn red and you'd have to go fix them. So for us, the AI magic is in thinking through, like, how do we use that technology to make the user experience even better on top of this already fantastic primitive, as opposed to thinking like, how do I use AI to paper over the fact that the primitive is kind of wrong?
Wow. Well, Adam, you have given us a ton to think about, and I think we definitely have to return to this topic as System Initiative grows and matures. So this will not be your last journey to Day 2 DevOps.
Woohoo!
But thank you so much for being a guest today on Day 2 DevOps. And listeners, virtual high fives to you for tuning in. If you have suggestions for future shows, we'd love to hear them. Hit either of us up on LinkedIn or send some feedback via packetpushers.net/follow-up. You can find me, Ned Bellavance, at nedinthecloud.com and my amazing co-host Kyler Middleton blogging over at letsdodevops.com. And we're both active on LinkedIn. Stop by, say hi. If you've got a way cool cloud product you want to share with our audience of IT professionals, you could become a Day 2 DevOps sponsor. You'll reach several thousand listeners, all of whom have problems to solve. Maybe your product fixes their problem, but they'll never know unless you tell them about your amazing solution. Find out more at packetpushers.net/sponsorship. Until next time, just remember that doing DevOps is awesome, and so are you.